Okay, today guys we're going to look at section 17.2, the sphere and hemisphere. Excuse me. So again, sphere is a 3D ball, okay? So the only thing we need to know is the radius of that 3D ball. To get the volume of it, so that means what would fit inside it if it was an empty ball and we wanted to fill it up with something. The formula for volume is 4 over 3 pi r cubed. And the surface area, so all around the outside, if we were to wrap it just exactly the size that it is, it's 4 pi r squared. So again, sphere, it's a 3D shape, okay? It's like a basketball or a football or a tennis ball. Okay, now hemisphere is half a sphere. Now the hemisphere formulas are given in your book, but they're not given in your logbooks. So you're not going to have the hemisphere formulas, but all you have to do is half this. So if you want the volume of a hemisphere, you just half your answer when you get the volume. Or if you want the surface area of a hemisphere, you half this. But just remember, the surface area of a hemisphere is like as if you cut a ball in half, so you also have the circle on the top. Alright, so it's like the flat circle plus the curved surface area on the outside. So if you half this, you get the curved surface area, and then you'll have to add on a circle on the top. But we'll do an example of that in a minute. Okay, so the first example we're going to do, taking pi is 3.14, find correct to one place of decimals the volume and the surface area. So here we have our sphere. It has a diameter of 16. So always be careful to check that they're giving you the radius, not the diameter. If they're giving you the diameter, you need to half it to get the radius. So the radius is 8. So half of 16 is 8. So volume of a sphere is 4 over 3 pi r cubed. Okay, so 4 over 3, 3.14, r is 8. Into your calculator and it'll do it all for you. So you get 2143.57 centimeters cubed. So your units in this chapter are important. Volume is always cubed, area is always squared. Okay, so whatever you're starting with. It wanted it to one place of decimals. So when you're doing one place of decimals, it means keep one number after the decimal place, but the next number does affect it. So if this is 5, 6, 7, 8 or 9, that number goes up 1. And because this is 7, this goes up to 6. So my answer to one place of decimals is 2143.6 centimeters cubed for the volume of the sphere. So then part 2 is the surface area. So again, surface area is 4 pi r squared. It's just a matter of filling it in into your calculator. And again, one place of decimals. So again, we look at this one. If it's 5, 6, 7 or 8, that goes up by 1. If it's not, that stays the same. So in this one, the 8 stays as the 8. Okay, and there's your volume and surface area of a sphere. Nothing too difficult there. Okay, so question 3 then in exercise 17.2 says the length of the radius of a solid hemisphere is 5 centimeters. Find in terms of pi the volume and the total surface area of the hemisphere. So this was one of the questions I asked you to do yourselves, and a lot of you had problems with it in that he didn't give it in the correct terms. So and then for the total surface area, you might have forgot to add on the top. So I'm just going to go through it with you. So part 1, write down your formula for volume. So it's a hemisphere. So 4 over 3 pi r cubed. Okay, so this is the full sphere. We're going to have our answer afterwards. Okay, so I wanted it in terms of pi, which means you don't press change on your calculator. Whatever your calculator gives you with the pi, that's what you keep. Alright, now this is a full sphere. So divide by 2 to get the hemisphere. So when we divide by 2, we get 250 over 3 pi. Alright, then part 2 says total surface area. So let's look at the hemisphere. So we have a formula for surface area of a hemisphere, which will give you all the outside. But don't forget about the circle on the top. Alright, so total surface area of a sphere is 4 pi r squared. And we're going to put that over 2. And then we're going to add on a circle. So the area of a circle is pi r squared. Okay, so 4 pi 5 squared over 2 plus pi 5 squared. Into your calculator and you'll get 75 pi centimeters squared. This is centimeters cubed up here because it's volume. So when it says in terms of pi, you actually have less work to do. You're just leaving it in terms of pi. Sorry. So you just fill all this into your calculator and you'll get 75 pi. So just make sure you're reading what the question's asking you to do. Okay, and remember, if it's a hemisphere, you have that circle on top to add on. Okay, another question that I did out was question 4. So question 4 said the volume of a sphere is 288 pi centimeters cubed. In this question, they've given you the volume. Don't forget this pi is part of the answer. So a lot of you probably dropped the pi if you were doing it and had difficulty then. So write down volume of a sphere. So volume of a sphere is 4 over 3 pi r cubed is equal to 288 pi. Alright. Then you want to find out the first thing we wanted to find out was the radius. Okay, so we want to find out r. So we keep r on its own. At the moment, 4 over 3 pi is being multiplied by r cubed. So the opposite of multiplying is dividing. So I bring it across the equals and I divide. So I'm putting 288 pi over 4 over 3 pi. So then work that out. R cubed is 216. Now we're used of r squared. We're not used of r cubed. But there's a button on your calculator to do it. The cubed root. Alright. So the opposite of cubing is the cubed root. So you just find that button that has a little mini tree. There's also a button that you can put in any number here, so you can use that one either and put in the tree yourself. So when you get the cubed root of 216, the answer is 6. So your radius is equal to 6. Okay. Part 2 then said find the total surface area in terms of pi. So surface area of a sphere, pi r squared. Fill in 6 for r, into your calculator. And it said in terms of pi, so 144 pi centimeters squared, and that's that. Okay, so for homework, what I want you to do is exercise 17.2, page 401, questions 1, 2, 6, 7, and 8. So let's have a look. Question 1 is straightforward. It's getting the volume of a sphere, volume of a sphere, volume of a hemisphere. Okay, so just you get the full sphere and divide by 2. Be careful here. If they give you the diameter, you need to get the radius. Alright. Second question is surface area of these 3. So again, your formulas. Question 2, that's 2. Question 6. The surface area of a sphere is 36 pi. So they've told you the surface area, so write down the formula for surface area, let it equal to that. Find the volume. So you'll have to find out r and then put it back into the volume formula. And they want your answer in terms of pi. Question 7. A container is in the shape of a cylinder on top of a hemisphere. So in the last section we did cylinder. Okay. Now the tricky thing in this is that this radius is 3, which means this is 3 here. Which also means that this is 3 here, because the radius is 3. So if you take 3 off of that 15, that gives you the height of the cylinder. That's the only tricky part there, to see that. And once you've seen it once, you'll know what to do in future. So remember, that's a circle, and it's a circle at the bottom. So the radius is from the center out, and that's telling you the radius there. So the radius here is 3, but this is also a radius from here out to the edge, so that's why that's 3. So this 15 take away 3 leaves you with 12 for the height of the cylinder. So they want you to find the volume of the container, so you're going to do volume of the cylinder plus volume of a hemisphere, and you're going to add them together. And it says correct to the nearest whole number, so then you'll round it to the nearest whole number. And the last question I want you to do is 8. A cylinder and a sphere are shown on the right have equal volumes. Find the length of the radius of the cylinder correct to the nearest centimetre. So you can find the volume of this and then let it equal to, so you write down formula for volume of a cylinder, formula for volume of a sphere, fill both in with what you know. You'll get the answer for this. You won't be able to get the answer for this because you don't know R. So you let that equal to that and you'll be able to solve for R then. Okay, if you have a problem, let me know. Tomorrow we're going to look at the more difficult questions in this section, which involve putting objects into liquid and different shapes within shapes. So we'll have a go at them tomorrow. Okay, thanks.